Good morning and hello students. I hope so you all are safe at your home and happy with your family. But now let's start our study. It's so important. So now we are starting our first chapter from our mathematics of our grade 9 maths chapter, that is the number system. Okay, so it's a very easy chapter to all of us and so easy chapter. And now here we learn about the numbers. Also we learn about the some new kinds of numbers. Okay, so here, as you know that all of you know about the number line, and whenever a number line, if you think that you are walking on the number lines and you are collecting the numbers, then I think so you all have learned already the some kinds of numbers, some types of numbers that I write on their board. Okay, so first here you can see here it's a natural numbers. So natural numbers, you all know that. So natural numbers means the numbers that we count or the number which are present. For example, 1, 2, 3, 4, 5, 6, 7 and so 8, 9, 10, 10,000, 1,000, 1 lakh and so till infinity. All that numbers which are whole and complete, that all numbers called as a natural number, and natural number denoted with the symbol n for a natural. So natural number denoted with the symbol n. So it's a set of a natural number which includes 1, 2, 3, 4, 5, 6, 7, 8 and so numbers. Now the second type of numbers, as we know that we just revising that. So second type of number, whole numbers. Okay, we just said that if we add 0 in natural numbers, then it will be it is a set of whole numbers. So whole numbers is a set of, just we have to add 0 in natural numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so till infinity. You can count more and more numbers for the whole numbers. So whole numbers is a set of numbers which include 0 and natural numbers. So whole numbers denoted with the symbol W, with the symbol W for the whole. That is the whole number set. Now, if you want to count some negative things like minus degree temperature, for example, minus degree temperature or negative things, or if you want to subtract, or whenever the number comes, negative number comes, then we got again another set of numbers. That numbers is called as integers. Now integers, which includes all positive numbers, 0 and all negative numbers. So integer is a set of all positive numbers, 0 and the negative numbers. You can see here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 20, minus 10,000, minus 1 lakh. You can go in front and in front. Again 0 and plus 1, plus 2, plus 3, plus 4, plus 5. That you already watch it on a number line. So it is a set of negative numbers, and the set is denoted by integers. The number is denoted by with the symbol Z. Actually, if you go through your textbook, then you can see it that the Z is a Greek letter called as Z. That means to count. Its meaning is to count. So that number, the set of a number which includes all positive numbers, 0 and negative numbers, and that whole set is called as integers. So in integers we can conclude all types of a number, all positive, negative and the 0. Now once again there are some kinds of a number. For example, if I write here a number 1/2, if I write here number 3/4, if I write here number -20/21, so where we can denote or where we can present this number? So such kind of a number, that number is called as a rational numbers. Last year actually in first lesson of our grade 8 mathematics, we already discussed about that the number which are in the form of P/Q, rational number. The same thing, or the word includes the word ratio. So ratio means rational numbers. So number are the numbers which in the form of P/Q, like that. You can see here 1/2, here numerator and also denominator over here. Here is also numerator and denominator over here. So such a kind of a number which in the form of P/Q, but here the quotient or here the denominator never 0, Q never 0. Okay, so such a kind of a numbers is called as a rational numbers. Already we discussed that kind of a number or that type of a number last year in a grade 8 maths. Okay, so numbers which are in the form of P/Q and Q does not equal to 0, and this kind of a number is called as a rational numbers. So here we revised all the kinds of numbers, but now I give you some example, or I give you whole format of that number system, that which numbers include in which number. For example, you can see here a natural numbers includes in a whole numbers, and whole numbers is set of 0, 1, 2, 3, 4 and 5 and 6. That whole numbers, this all numbers includes in a integers. These all numbers include in a integers, but these integers also we can show in the form of P/Q. So this integer all also includes in the rational numbers. Okay, so now from one figure we can see here how that number include or relate each another. Okay, students, if you see the picture or the diagram on the board, you clearly now understand the numbers, how to relate numbers each other. If you take the set of natural numbers, the natural number include 1, the n is the symbol of a natural number. The natural number includes 1, 2, 3, 4, 5 and so numbers. But if we just add this natural number completely in the whole numbers, so it will become this will now a complete set of whole numbers. It includes all that natural numbers and 0. So 0 plus this all natural numbers completely makes a set of whole numbers. So whole numbers we denote with the symbol W, and you can see here whole numbers means 0 plus set of all natural numbers. Again, if you see clearly, whenever that whole numbers 0 and again we add some negative numbers in it, then we got a set of integers. That means a Z, it is the symbol of integers. So in a set of integers we get here numbers, all negative numbers, that means -1, -2, -3, -4, -5 and so all that negative numbers. Also we include here 0 and all positive numbers, that is 1, 2, 3, 4, 5 and 6 and so 6, 7, 8, 9, 10 till infinity. You can add many such kind of numbers. So it is a set of integers. That means you clearly understand over here that natural numbers with 0 makes whole numbers. Natural numbers is a set of numbers, that is 1, 2, 3, 4, 5. But natural numbers with 0 make a set of whole numbers. And then 0 and positive number including negative numbers make a set of integers. That means all positive 0 and negative numbers completely makes a set of integers. But now these all integers with some kind of a ratio type numbers, that are fraction numbers, some kinds of fraction numbers which are in the form of 1 upon 2, 3 upon 4, that means which are in the form of p upon q. Such kind of numbers is called as a rational numbers, which is denoted with the symbol q. Q means a quotient. For q means a quotient, it is denoted with the symbol q. So q is the set of rational number which are in the form of p upon q, and where q, that means denominator never should be equal to the 0. So this kind of a number we can show in the form of 1 half, 3 upon 4, 5 upon 6. We can write here minus 7 upon 3 or such a kind of one. We can write here also 7 upon 7, that means 1, and 6 upon 6, that means also 1. So we can also represent all integers in the form of rational number. So natural numbers, then again whole numbers, then again integers, that all numbers includes in a group of rational numbers. So rational numbers is the bigger numbers group. So here we learn about still rational numbers. So what we can say here? We can say here all natural numbers are whole numbers. All natural numbers are the whole numbers. Also we can say here all whole numbers are integers. Also we can say here all whole numbers are integers. And again we can say that all integers also rational numbers. But opposite to that, we can say here all rational numbers not any integers, all rational numbers not any integers, also all integers not any whole numbers. Also we can say that all natural numbers are not a whole numbers because it includes 0 to the set of natural numbers. I hope so now you understand about the numbers and its relations. Now let's we try our first example from your textbook, page number 3. There is one example and we can solve that example after some time. So let's solve that example. Okay students, if you check out the page number 3 from your textbook, math textbooks, then you can see here there is one example. In that example they ask one question to us, that example 1, are the following statements true or false? Give reasons for your answers. So here let us check out that examples or that statements. That first statement is every whole number is a natural number. So what is the meaning of that statement? This means that every whole number, each and every whole number is a natural number. But it is not true, because in a natural number is a set of 1, 2, 3, 4, 5, 6, 7 and 8 and 9 and 10. But whole number is a set of 0, 1, 2, 3, 4 and so 0 is the different here. 0 is the one number that not included in a natural number. So the statement is not true here. So what we can say that the statement is a false. What we can say that the statement is a false because, so we can give here reason, because 0 is not a natural number. 0 is not natural number. So the given statement that every whole number is a natural number is a wrong or is a false. So that is the answer of that first statement. Now let us check out the second statement. So in second statement what we have asked, every integer is a rational number. Now as we know that integer means which numbers? All positive numbers, 0 and non-negative numbers, that all numbers is a rational number. So here they say that every integer is a rational number. So yes, we can represent every integer, that means all positive numbers, 0 and all negative numbers also we can represent in the form of p upon q, because rational number is a set of a number which are in the form of p upon q. For example, if you take the -3, so we can write that -3 is -3 upon 1, so it is a then rational number. Also we can write 0 as a 0 upon 1, so again it can be a rational number. Again any positive number like 131, so we can write 131 upon 1. So again we can write every integer in the form of p upon q. So we can write in the form of p upon q, that all integers we can write in the form of p upon q. Hence we can say that every integer is a rational number. So the statement is a true over here. So we can write here that the statement is a true because integer can be in the form of p upon q where q not equal to 0, where q not equal to 0. So the statement, our second statement is that every integer is a rational number is a true because integer can be in the form of p upon q or integer are in the form of p upon q. So p upon q, so where q is not equal to 0. Now the third statement over here, third statement we have that every rational number is an integer. That means they say that each and every rational numbers. Now as we know that rational numbers means the numbers which are in the fraction form, that means which are in the ratio, that means in the form of p upon q. But whenever we check out the integers, integer means which number? Integer means number that is 0. Then positive numbers. Positive numbers means which numbers? That is 1, 2, 3, 4, 5, 6, 7 and so and so. Again, all negative numbers, that is -1, -2, -3, -4, -5. That means such kind of a numbers is called as an integers. But here the sentence that every rational number. But rational numbers means what? Rational numbers means the numbers which are in the form of 1 upon 2, 3 upon 4, -7 upon 3, -2005 upon 2006. So such a kind of numbers are not integers. So the statement here is false because rational numbers, every rational numbers cannot be integers. All integers can be rational numbers, but every rational numbers cannot be an integers. So here we can say that the statement is a false because, like for example, the number like 3 upon 4, 1 upon 2, -3 upon 5, or you may say that -7 upon 8. Such a numbers not an integers. Such kind of numbers not an integers. So the statement over here, that is that every rational numbers is an integer, is false. So I hope so you understand that example. Now we learn about the rational numbers. Now already I think so you learn that how to find out the rational numbers between two numbers. So that type of example we are now, our example 2 is on that. So now we are looking for that example. So we are learning now example 2. Okay students, so if you check out the page number 4 of your math textbooks, then you can see here there is example 2, and on example 2 they ask us that is the find 5 rational numbers between 1 and 2. So what we have to find out? We have to find out 5 rational numbers between 1 and 2. So between 1 and 2 we have to find out the rational numbers between 1 and 2. There are two methods to find out the rational numbers between the 1 and 2. So let us solve that example with solution. First method, that is the solution. That is our first method. So let's take that number. So what we have to do, take that two numbers, that is a 1 and 2. So what we have to do, we have to add that two numbers. So we have to find out 1 and 2, and between that two numbers we have to find out any 5 rational numbers between these two numbers. So what we have to do first, let's add 1 plus 2 and divide it by number 2. So if you do that, then we got one number over here, that is a 2 plus 1, that is a 3 upon 2. So we got over here one number, that is a 3 upon 2, that is a number which is between the 1 and 2. It is the first method in which we have to add that two numbers to each other and divide it by the number 2. Then we got one number which is between that two numbers. So here we got one number, that is the 3 upon 2. The number is between the 1 and 2. Again, if you want to find out more numbers, because here we find out just one number. Now we have to find out more 4 numbers. So what we have to do now, we have to add that two numbers, and again we have to divide that numbers by 2. So let us find out again another number. So it is the first way. Again we have to take these two numbers. So let us take these numbers, that is 3 upon 2 plus 2 upon 2. So let's solve that number, that is 3 upon 2 plus 2. So let's do the cross multiplication over here, that is the 3 plus 4 upon 2, and again total number is divided by 2. So again here we got that the 4 plus 3, that is 7 and 2, and this 2 is multiplied over, so 7 upon 4. The 7 upon 4 is also one number between the 3 upon 2 and the 2. So here we got again one number, that is the 7 upon 4, and again this number. Again we have, by this method, again we can add any two numbers and find out the more numbers between that two numbers. So again let's find out one more number, like that 1 plus 3 upon 2 and whole number divided by 2. So we can solve here, that is the 2 into 2 plus 3 and 2 ones are 2 and divided by 2. So here we got that is 2 plus 3, that is the 5, and 2 2s are 4. Again we got here one number, that is the 5 upon 4. So that is also number. So here we find out the three numbers, 5 upon 4, 3 upon 2, 7 upon 4 and 7 upon 4. That three numbers we find out, but we have to find out the 5 rational numbers. So here we find out 1, 2, 3. Now let's find out more two numbers. So let us find out, now let us take that two number, that is 5 upon 4 plus 3 upon 2. So 5 upon 4 plus 3 upon 2 divided by 2. Let's make the number same. So 5 upon 4 plus 3 2s are 6 and 2 2s are 4. So here we make that number same and divide by 2. 5 plus 6, that is 11 upon 4 divided by 2, and again 4 2s are 8, and means 11 upon 8. So that number is also the number between that two numbers. So here got one more number to us, that is the 11 upon 8, the 3 upon 2. So here we got the fourth number, that is 11 upon 8. How we find out that number? Just adding that two numbers and then dividing that numbers by 2. We can find out more numbers. Now let us find out one more number. So we can complete our example. So let us find out one more number. Like that. Now let us take this two number, that is 7 upon 4 plus 2. So let us take 7 upon 4 plus 2 and then again divide the number by 2. So again let's do the cross multiplication. It is 7 plus 4 2s are 8 and then 4 1s are 4 and again whole number divided by 2. Then 7 plus 8, that is the 15 and 4 2s are 8. 4 2s are 8. So again we find out here one more number, that is the 15 upon 8. So that is the 15 upon 8. That number is between the 7 upon 4 and the 2. Now here we find out that 5 numbers between the rational numbers 1 and 2. By which method? By the method adding two numbers and dividing it by 2. By that method we find out over here, that is the first number is 3 upon 2, 7 upon 4, 5 upon 4, 11 upon 8 and the 15 upon 8. That all numbers are between the 1 and 2. So it's a first method to find out that numbers between the 1 upon 2. But I hope so the second method is very much easy for us. So now again we can find out the numbers, rational numbers between 1 and 2 by another method. So it's your first method. So write it down and if you have any query then ask me. Now in this method again I say that we have to add two numbers and then divide that two numbers by 2. Then we can find out middle numbers between that two numbers. For example, first we add 1 and 2 and then we find out the middle number, that is the 3 upon 2. Then we add 3 upon 2 and the 2 and then we find out the number 7 upon 4. Then again we add the 1 and the 5 upon 4 and again 1 and 3 upon 2 and again we find out the number 5 upon 4. So it's the first method. It's a little bit difficult than another method. Now let's talk about the another method. Okay students, so again now we are learning about the second method, how to find out the rational numbers between the given numbers. Our given numbers over here is the 1 and 2 and we have to find out the rational numbers between, we have to find out 5 rational numbers between 1 and 2. Now it's the second method to find out the numbers. Now let's here take the number 1 and another number is the 2. Now we have to mention that numbers with the now we have to find out 5 rational numbers between 1 and 2. So what we have to do, we have to find out 5 rational numbers. So add one number in a 5. That means 5 plus 1. That means what? 5 plus 1 is equal to 6. So 5 plus 1 is equal to 6. So if you represent that these two numbers in the form of a 6, then we can easily find out the 5 rational numbers between 1 and 2. So how can we represent? We can represent this one like that. 6 upon 6, because 6 ones are 1, 6 ones are 1. So we can represent this one in the form of 6 upon 6. Again, we can represent these two in the form of 6. For example, like that, 12 upon 6. So 6 ones are 6, 6 twos are 12. So we can represent 2 in the form of p upon 2, like 6 ones are 1 and 6 twos are 12. Here one condition or one thing, notice that we have to take denominator equal. We have to take what? Denominator equal. So we have to find out 5 rational numbers between 1 and 2. So we add 5 plus 1 and take a number 6 first, and then we have to express these two numbers in the form of a 6, where our denominator should be a 6. So 6 upon 6 is the 1. So we can represent 1 is equal to 6 upon 6, and also we can represent 2 is equal to 12 upon 6. Now we have 1, that means 6 upon 6 is our 1, and 12 upon 6 is our 2. Now you can easily write down the 5 rational numbers between that two numbers. So 6 upon 6 means you can write that again the next number is the 7 upon 6. Again you can write that the 8 upon 6. Again you can write that the 9 upon 6. Again you can write the 10 upon 6. Then 11 upon 6. And our last number is the 12 upon 6. So here you can see that 7 upon 6, 8 upon 6, 9 upon 6 and 10 upon 6 and 11 upon 6 is also a numbers between the 6 upon 6 and the 12 upon 6. But 6 upon 6 means our 1 and 12 upon 6 means our 2. So these all numbers are between these two rational numbers. These two numbers, between these two numbers 1 and 2. So we can represent easily by this method we can easily find out the 5 rational numbers between 1 and 2 by this second method. I think so it's so much easy method, and I hope so you understand it very well. It's easily, again I am going to tell you that if you want to find out the 5 rational numbers between any two numbers, then first add 5 or that number given in a problem and plus one number, that is 5 plus 1 6. Then what to do? The given number we have to represent such that their denominator should be 6. Like 1 we represent in the form of 6 upon 6, then be 6 1s are 6 1s are 1, so 6 upon 6. Again 2 we can represent in the form of 12 upon 6, like 6 1s are 1, 6 2s are 12. So here we take care that the denominator always must be 6. Then easily you can find out the numbers between 6 upon 6 and 12 upon 6. We know that already number line and how to represent the numbers on that number line. So easily you can find out. For example, if you take a number line and over here is the 1. So here is the 1. So 6 upon 6 we can represent the 1 6 upon 6. And if we divide it properly, here we can represent the 12 upon 6. And if we divide it properly, 1, 2, 3, 4 and 5 parts. So we can easily show here 7 upon 6, 8 upon 6, 9 upon 6, 10 upon 6, 11 upon 6. So that all numbers are between 1 and 2. That all numbers are between 1 and 2 with the equal distance. So that is the easy method to find out the rational numbers between any two numbers. So I hope so that that example 1, also an example 2, and example 2, both methods you understand very well that how to find out the rational numbers between given numbers. So from that example, what we can say that we can find out infinitely many rational numbers between any given two rational numbers. If you give any two numbers and anybody says that find out the rational numbers between them, so you can find out infinitely many rational numbers between that two numbers, between that given two numbers. So I hope so you understand it very well. So now afterwards